Next part is to know about dimensionless. Dimensionless number. Itself, this wording says something. Dimensionless. Dimensionless is the quantity, any quantity or any property which has no unit. That is called as dimensionless. Specific gravity. Specific gravity is a ratio of what? Specific gravity S is a ratio of density of any liquid to density of standard liquid. We take standard liquid as a water. In this case, both are having same unit, kg per meter cube. If we will take ratio of these both, ratio will get cancelled and we will get 1. Means specific gravity we say as a dimensionless number. Okay. But here in this dimensionless number, we are going to do study of group of some properties. Which properties? One is a flow property, one is a dimension property. Flow property which will indicate about its speed. G, V is the speed, N is the RPM. Okay, G, acceleration due to gravity. Unit of this we will say meter per second. Unit of this we will say s raised to -1 per second. It will take RPS, revolution per second. Speed can be expressed by RPS or RPM. RPM means revolution per minute, or RPS, revolution per second, is per second. S raised to -1. Okay. G means what? Meter per second square. Velocity meter per second. So in all these quantities, on all these units, you will say here you are finding what? Time, per unit time. Okay. So these properties, all the properties are having time. Okay. That is why these properties are called as flow properties. Flow properties. Okay. The properties which will indicate dimension. Good. The property which will indicate dimension. Dimension. This is the object, regular size. This is the length. This is the width, height. Width can be expressed by another letter, breadth also. So length, width, breadth, height. If the object is of rectangular shape, block shape. If the object is of circular shape, then we will have dimension of this circle, this diameter. Okay. So, group of the properties which are indicating or which are giving information about its dimension, its size, all these properties, for example, length, width, breadth, height, diameter, all these properties are coming under the category that is geometric property. Geometric. Geometric properties. So this is the next group. First group was a flow properties. Second group is of geometric properties. Means these properties are giving information about the size of that object. Okay. Third category is where the property is giving information about nature of the fluid. Means that third category is or group. Third group is of properties which will give nature, information about the nature of that fluid. Which are the properties? Density. Density is giving information about its mass per unit volume. Is how much that object or that fluid or that substance is having mass per unit meter cube. For 1 meter cube, what is the mass of that object? And based on that, we say that that object is a denser, that object is a lighter. Air, we say light. Density of air is 1.2 kg per meter cube. rho air, but density of water is 1000 kg per meter cube. By observing this value, what we know that 1.2 and 1000 is about 1000 times. Means we say air is a lighter substance and water is a heavier substance. Mercury density is highest, that is 13,600 kg per meter. Means mercury is a fluid or substance that is the heaviest fluid. It is having most, higher value of the density. Means this is a property which is giving information about its mass for the water. Next is viscosity. Viscosity will give information us about how much that fluid is flowable. Kerosene, oil, petrol, these are easily flowable. Honey will have resistance. This honey will have more viscosity. Kerosene, petrol will have low viscosity. This higher viscosity fluid will be honey. Okay, low viscosity fluid will be petrol. So such like there are some properties. Okay, density, viscosity, okay, surface tension. Okay, so that group is fluid properties group. Third. Okay, so now we will have dimensionless number means group of some properties which will contain one dimensional property, one flow property, and one fluid property. For example, Reynolds number. What is formula of Reynolds number? We have seen rho Vd by mu. Rho Vd by mu. Here we will see this is a group of four properties. Reynolds number. This property is giving information about nature, that is a fluid property. This property is which property? Dimensional. Means geometric property. Geometric property. This property is giving information about speed. This is which property? Flow property. Flow property, geometric property, and rho and mu. Rho and mu both are which properties? Fluid properties. Rho is giving information about its mass per unit volume and it gives information about its thickness, whether it is a thin or thick in a nature. Here are two fluid properties, one flow property, one dimension property. By a combination of these four properties together, that becomes Reynolds number. And this Reynolds number has no dimension. That is why it is called as dimensionless. Likewise, there are five numbers we are going to see. Reynolds number, Euler number, Weber number, Prout number, Mach number, like that. Okay. Each number will have some formula. But for that there should be some basic. So all these properties actually, all these numbers are ratio of inertia force to different forces. Inertia force to viscous force. That ratio is nothing but Reynolds number. Then inertia force to viscous pressure force, inertia force to gravity force, inertia force to surface tension force, inertia force to elastic force. Likewise, there are different ratios, 5 ratios we are taking. And these 5 ratios will be 5 dimensionless. So we will see one by one. Okay, let us see first of all Reynolds number. So first number, take Reynolds number. Write down definition of this. It is ratio of inertia force to viscous force. It is ratio of inertia force to viscous force. So as here I mentioned, it has no dimension, clearly indicate force Newton unit is Newton, viscous force unit is Newton get cancel, this it is a dimensionless number. Now how? Further that probability by mu, how to obtain? That is we will see now. So inertia force is written, inertia force is written like this, rho a v square. Rho a v square. Inertia force is given by this formula, rho a v square, where rho is the density of that fluid, a will be area of the pipe or channel through which that fluid is passing, and velocity v by which that fluid is flowing. Rho a v square, inertia force. Okay. Next, viscous force. Viscous force formula. Now viscous force, how to write? We know that Newton's law of viscosity. Newton's law of viscosity, tau is equal to mu upon dy, where tau is a shear stress. So shear stress into area is a shear force. Especially viscous force is which kind of force? Shear force. Is the force which is acting in a parallel fashion. Two planes are sliding over each other, or two layers of the fluid are moving one another. Then there is a friction between these two layers. Okay, there is some resistance offered by both these layers to one another. That resistance is nothing but viscous force. How to write it? Tau into area. Now tau is what? Tau is by Newton's law of viscosity mu into du upon dy. K into P. Okay. Further, this we will write as mu. Du we will take here as a velocity. This y we will take as a dimension. This dy is representing what dimension. So for the dimension we will take dimensional property L. For the du we will take flow property. Du is what? Velocity. For that we will take property velocity. And this is what? Area. Now area is what? Anything, any shape. Its area is what? Length into width. Now here these both are what? Sizes. Size we indicate by the letter L. Is actually that is area is what? Area is L into L. Means L square. Area is L square. Okay. So here this is what? Mu v L. Because this L will get cancelled with this square. So mu v L. Okay. Now we will take here ratio. We will put inertia force, that is rho a v square. Okay. Rho a v square. Here rho a v square divided by here mu v L. Rho a v square, and here viscous force mu v L. This we will put. So in this case, this v velocity will get cancelled here. So with this square. Already we have seen A means area. Area is product of length and length. Further, it is what? A means L square. So rho L square into V divided by mu by L. Then this L will get cancelled with this square. So finally we will get here rho L V by mu. So Reynolds number we will get rho V L by mu. This we can write in this way, rho V D by mu. So finally we got the formula for Reynolds number in the form of dimension as a length. This is another dimension as a diameter. So we can write this formula in the form of diameter, is rho dd by. Thus we use in the experiment laminar flow, Reynolds laminar flow. Okay, that formula is rho dd by to find the Reynolds number. This is what dimensionless number we find by using the basic formula, that is inertia equals to viscous force. Now its importance. Every number has some importance. Importance means where these are used. Okay, so Reynolds number is used to decide the flow. Right now, significance means importance. Reynolds number decide type of flow. Means we have seen in the practical, when the Reynolds number is less than 2000, we were saying that number is a laminar flow. When the Reynolds number is crossing 4000, we were saying that flow is a turbulent. Means whether the flow is laminar or turbulent, that is decided by the value of Reynolds number. So importance of Reynolds number is, that is what significance.